Okay, welcome to my latest and greatest video release, an introduction to map scores. I'll be on the red carpet all evening. Feel free to take pictures and talk about the tux I am wearing. MAP stands for Measures of Academic Progress. If you're following along in the notes, it's kind of self-evident. And the idea here is that it is meant to assess people as they develop throughout the school year and look at student growth over time rather than the traditional standardized assessments that have been used for accountability purposes, where you are just trying to make sure that the school is performing well enough, or where it's performing relative to other schools in the district, state, or whatever. Main ideas in this presentation are to talk about map assessments, what they are, how they're used, talk about the Roche unit scale, which is really one thing that makes maps even better in more dimensions, in more ways than standardized assessments, and then how we can ultimately use map data. And this is a challenge that a lot of teachers are facing these days. They're not sure exactly how to use this stuff. So, features of map tests. Maps provide a challenge for all students because they are adaptive, so they can tailor make an assessment for any particular student, whether they're in 4th grade or 5th grade, and whether or not they're above or below grade level. And the Roche unit scale makes this possible as well. Another great thing is that it provides accurate feedback, and that the results are received immediately, and that you can measure growth and progress for a single student with relative ease, whereas if you look at WKCE outputs or other standardized tests, Iowa tests of basic skills and so on, they are just, again, a snapshot, and you can get individual student scores, but you would have to do a lot of extra work to link those scores in the past and going forward in the future. So there are two different types of map assessments in the general sense, and I'm talking about the map test for older grades at this point. We'll talk about map for primary grades a little later on, and that'll be in a different video actually. I'll just kind of go over the output. But there's a special one for primary grade students. So the survey with goals is a little bit longer. You have these overall score for a subject, plus you have different sub-construct goals, which really breaks, like for instance, math down into all its component parts. And the map testing, or NWEA, the organization that makes these things, has kind of mapped out how math develops over the ability range rather than just across grade levels. The survey is just a shorter version, and you get a quicker snapshot. But the screen kind of looks like this. You have somebody's name, click a button on Start Test, and it would start. Questions are your basic multiple choice format. You have this, kind of information on the top: reading test, name, and question number 1, and then they have item number and so on. Reading comprehension. Math is similar. And the idea behind all this in the map testing is that the computer adapts to whether or not you are answering questions correct and demonstrating high levels of proficiency, or whether you are getting questions wrong and demonstrating low levels of proficiency. So you'll start out getting kind of a mid-range question, and if you get it right, they give you a harder one. If you get that right, they give you another harder one. And they keep going up until you get it wrong, at which point they give you an easier one. Easier one, get it wrong again, easier, get it right, harder, easier, easier, harder, easier, easier, harder, and so on. Until, if we look at the standard errors, these confidence bands associated around each question, if you get this right, I say that my best guess is that your ability is right here on this scale, and this is the Roche unit scale, and we'll talk about this in a little while. But my confidence about how accurate I am is pretty doggone low. It could be anywhere from down here to up here. Now, with each subsequent question and how you answer, my confidence bands are getting smaller and smaller until I get that you have, or that I have assessed your proficiency or your skill level very accurately. Now, this is helpful in another way, in that for typical tests, I can only really talk about grade level stuff. So in other words, once you're going above the advanced range, I don't have a whole heck of a lot of items that really target where you are in those ability levels, because if I'm taking a 4th grade assessment, I am giving you 4th grade content. And if you get a ton of questions right, I say you're advanced. But do I really know whether or not you are above grade level? You know, when we talk about grade equivalency scores, and if I'm in 4th grade and I get a grade equivalency of 7.6, that just means that I do the content of a 4th grader as well as a 7th grader would. So it doesn't tell me anything about 7th grade content. This does. It keeps giving actual questions that are actually harder and harder and harder, and that really represent a meaningful difference in, say, something like math ability. And as we look through in a second, these different the different ways that they've mapped this out, that'll become a little more clear. It happens, or the same thing's true on the bottom end of things, where I can look at people who are performing below grade level and see where they are underneath and see what skills they actually have, rather than just the fact that they're at my grade level. I'm going to look at questions where they're at. And the thing that makes this easy or possible is this idea of this RIT scale, or Roche unit vertical scale. Now, the great thing about it is that it goes across grades. Doesn't matter about age, doesn't matter about grade. It just looks at, basically, it looks at math skills like any other skill. Like if I'm measuring strength, I don't have particularly 4th grade exercises or 7th grade exercises. If I'm measuring how fast someone can run 100 meters, I'm just measuring the time, and that time is my measure of speed. This treats mathematics or reading or science or whatever the same way. And in just a second, I'll show you some of these broader or more detailed ways that the map people have looked at this stuff. As I was saying, the great thing is that if we look at the RIT scale, it is this continuous scale of measurement, and you kind of a range of, or a look at the range of what the unit values are and what the value is at each grade level. So in other words, in 3rd grade, you should be around this level. And the nice thing is that, say that we're talking about what to target or what content areas to target to teach a student at this level, well, MAP has kind of laid that out too. So if we want to keep kids always at, or in their ZDP, or their zone of proximal development, this is a great tool to see where each student should be. So if I'm looking at this, I have skills and concepts to introduce. And again, this is just getting their feet wet. So you look at skills in this range, 171 to 180, right? And this is things that you want to just get their feet wet with, not work on a whole lot, but just introduce them. Skills and concepts to develop, which is right at the top of their level, right, is the skills with a value of 161 to 170. And then the skills that you want to enhance and really refine are the ones that they have really already mastered in a basic sense. And so you get a really good detailed look at how things can actually work out. These things are broken down in a huge way. I'm going to pull up a different screen here, and what this is I have things like number sense here, and you have below 161, 161 to 170, 171 to 180, 189 to 190, and so on. And these are sample problems that fall into each one of those categories. Now I'm going to zoom in a little more to make sure that you can see these things. But so number sense. This is the general construct. Students understand and apply concepts of numbers, including representing, identifying, counting, comparing, ordering, equivalence, and number theory. Okay, that is the construct that you're trying to teach. An easy question below 161 is just basic counting. How many apples are there? As we get up higher, right? Now we're talking about fractions. As we go up higher yet, now I'm talking about numeric equivalency, trying to make sure that students understand differences between, or that numbers and number sentences represent the same thing. Now I work with rounding and place values. Now I'm looking at, again, fractions and regrouping and division. Now I'm looking at fractions again in simplification. Now I'm looking at algebra. And now I'm looking at even more complicated mathematical skills, all the way up to above 250. And as you can see, this really gives a detailed blueprint of how math skills, in particular in this case, number sense, develops. Same thing for estimation and computation. We're talking about process of computing and solving problems using whole numbers, blah, blah, blah. You can read that. I don't need to read it for you. But the idea is basically the same, right? I look at how these things are progressing, basic addition, double place addition, tens and ones, subtractions, multiplications, fractions, decimals, and division. And as I keep going up, the numbers, right, keep getting more and more complicated. The problems require greater complexity of skills. Now, of course, with anything, this is a theoretical look at how math skills develop in a broad sense, based on curriculum that has been taught for years and based on developmental theory and things like that. There are counter theories out there that say that this isn't the best way to talk about how these skills develop, but this has been working fairly well for a long time, and that's what they're going to stick with. Now, if we want to look at something like reading, it'll be very similar. And for reading, I have things like word recognition and vocabulary, reading comprehension, and so on. So word recognition and vocabulary. The girl is sitting at her desk. Very easy, hopefully. Read the sentence. One was very blue when his puppy was missing. The word blue means sad, talking about dual meanings and word knowledge. Reading story and comprehending things. And understanding the meaning of, in this case, engine. Again, looking at bonnets and trying to figure out what bonnet means. This is supposed to be something that measures context clues, but of course, if you know what a bonnet is, it doesn't really measure that issue, of course, validity issue. We have another one where we're looking at different forms or homonyms, and we're trying to differentiate between the meanings, talking about different types of articles, word parts, and word meanings, prefixes and suffixes, again, context clues, and so on, until we get up to this really kind of high level of comprehension. And that's basically how it goes. This really helps people to figure out where their students are. It can help people. I'm not saying that people are using this very well these days yet, because it is new and there is some kind of warming up period. But people can use this to really get a detailed look at what students should be learning. And ultimately, if instead of age cohorts we had ability cohorts, this would be an even better tool. But with the way the schools are structured now, well, it's not the greatest. Still kind of going with the old factory model of school where it's, as one person said, it's your date of manufacture that matters the most rather than your actual ability level or your needs. And here's just the evidence that norms are made for these things. If we're looking at somebody's students' profiles, you get this output where all your students are, what their grade levels are in each thing for each subconstruct. You can even break that down further into different goals and different subcomponents that you really want to focus on at different levels.